Hello, in this video lecture, we'll try to understand the basic concepts of the bipolar junction transistor or BJT, which is also popularly known as a transistor. Normally in daily general usage, it is called transistor. Actually, it is a bipolar junction transistor. This transistor is a very important solid state device which has revolutionized the entire electronic industry during the 60s. Here I have shown some simple images of actual transistors which are used in our lab or industry. Now let us know the inventors of this versatile electronic device called transistor. This versatile electronic device was invented or first fabricated by three popular scientists, William Shockley, John Bardeen, and Breton at Bell Laboratories. And of course, all the three people received the Nobel Prize in the year 1956 for this contribution. And I have shared the photograph for your reference also. Yes. Now let us understand what is the meaning of this bipolar junction transistor, why it is called so, what are the terminals of this device, what are the types of this transistor, and also how it is fabricated. For that, let us take up the introduction. The transistor is basically a three-terminal bipolar bijunction active semiconductor device which can act as an amplifier or oscillator. Actually, when you take up this, a little bit introduction, let me take the pen. So far we have already covered, I think many of you know what is your two-terminal semiconductor device, that is your PN junction diode. This is a PN junction semiconductor device which is popularly known as diode. One terminal is called anode A, the other terminal is called cathode. You know that this PN junction diode will work in forward bias and will not conduct in reverse bias, and hence it is widely used in your rectifiers. What is a rectifier? Actually, a rectifier converts alternating current AC to DC, direct current. That is its application. So this is a two-terminal semiconductor device which can act as a diode. Diode means two electrodes. One is anode, other is cathode, or P and N. This is normally known as junction, which I have already covered. Now what these people have done, they try to add one more part, one more terminal to this. If you connect one more terminal to your two-terminal device, then it will become a three-terminal device. This three-terminal device has many applications and they have called this as transistor. This was done by the three scientists about whom you have heard. So this three-terminal device is basically, as I have mentioned, used as an amplifier. Remember, this is one of the most important things. Only a three-terminal device can act as an amplifier, and a two-terminal device like a diode, Zener diode, tunnel diode, varactor diode, any type of diode, it will never act as an amplifier. They will act as rectifiers or regulators or some control devices, detectors or any other, but they cannot act as amplifier. Only three-terminal devices which you will come across in future classes, that is your bipolar junction transistor or field effect transistor or any other device. They can only act as amplifier. So this is the importance of your BJT or so-called transistor. It is a three-terminal device or component where the three terminals are, one is emitter, the other is base, the third one is called collector. It is a three-terminal device. A transistor is considered as a semiconductor analog of its three-terminal valve counterpart because this is all semiconductor devices. During 1950s, 60s, 70s also, early 70s also, there was valve technology. We used to call them as triode valve, but there were so many disadvantages or limitations. Therefore, from there onwards, we have come to this semiconductor technology or solid state devices. We call them as semiconductor devices or solid state devices. And this triode in those days was also a three-terminal device, which we used to use or work as an amplifier. Same emitter, base, collector, transistor also acts as an amplifier. That's why people consider this transistor as a semiconductor analog of its earlier valve counterpart, triode. Nothing more than that. Of course, just if you remember the name, it's enough. It's not very important. Right. So once you have understood what is a transistor is a three-terminal bipolar bijunction active semiconductor device which can act as an amplifier or oscillator. Yeah, as we have seen how to form a transistor. Earlier there was a two-terminal device. Now I have a three-terminal device. That means how do I form? Suppose I have a three-terminal device like this, P, N. I can add one P here. Then it will become PNP transistor with emitter base collector. Suppose I have same transistor like this, PN. I will add one N terminal here, NPN. That means by changing the type of semiconducting material that I am adding, the transistor configuration will also change. Its working will also change. So that's why if you observe this transistor carefully based on this, the meaning of the transistor can also be understood. Why? Because if you take up either PNP or NPN, you can see here between this PN, you know that there will be always a junction, PN junction. Of course, reverse bias, one more PN junction. That's why in this transistor, there are two junctions, J1, observe carefully, J2. Here also, J1, J2. So there are two junctions. And also if you observe carefully, there are two types of charge carriers. Holes, P means, as you know already, basic semiconductor physics says you, P means holes, N means electrons, and also holes. NPN, N means electrons, holes. That means there are two types of charge carriers. That is bipolar, bijunction. It has two junctions. In terms of names, if I say it is emitter base junction and base collector junction. Emitter base junction, base collector junction. Therefore, when you consider the schematic of your transistor or BJT, you can clearly understand that there are two junctions and there are two types of polarity carriers, both holes and electrons. Hence, it is called bipolar bijunction semiconductor device or simply transistor. Actually, transistor means transfer of resistor. That's why scientists have given this name. Transistor means transfer of resistance. So here the resistance is transferred because we'll understand while studying the properties. As I move from forward bias to reverse bias or reverse bias to forward bias, there will be change in the resistance. Of course, because of this change in the resistance, current will also change. We'll consider that afterwards. First, let us understand the basics of this. So once you understand this, explain the same thing here. As there are two types of charge carriers, both electrons and holes, it is rightly called as bipolar transistor. Similarly, as there are two junctions, it is also junction J1 between base and collector and base and emitter. J1 base and emitter, base and collector. So it has two junctions and two types of carriers. Hence, it is called as bipolar junction transistor. Therefore, this three-terminal device is rightly called as bipolar junction transistor. This is the most important thing that you should remember why a transistor is called BJT. It is a semiconducting device. Next, another most important thing is bipolar transistors are current regulating devices. That is, the current of the base or base current will actually control the activity of the transistor. That is, bipolar transistors are current regulating devices that control the amount of current flowing through them from emitter to collector terminals in proportion to the amount of biasing voltage applied to the base terminal. Very, very, very important. This IB base or VBE, which we apply base emitter voltage, which should be normally forward biased, and because of this you get the base current IB, which will be in microamperes. We will discuss that afterwards. So this current or base emitter voltage will control the currents of this IB, will control the currents of our operation of your transistor, collector current IC, and the emitter current totally changes IE. So that's why this transistor is always called as known as a current controlled device, or it acts as a current controlled switch also. Remember, when you consider the effect, field effect, that's a voltage controlled device, whereas a transistor or BJT is a current controlled device. Very important. Now, what are the salient points, are very important points that you should understand as far as about your BJT. In a transistor, the base region is always very, very, very thin. That's why while drawing your transistor schematic, what we do is we'll draw like this. Always remember, or you can say, so you can say that this will be your emitter. It should be very large, and this should be your base, very small. This should be your collector. Yeah, just remove this part and make a connection. If you observe carefully, your base region should be very, very, very small. Base region will be very small. That's why the current that is formed by this base current will be of the order of microamperes. This current will be of the order of microamperes, as you know already, and this will be in milliamperes. Collector current will also be in milliamperes. Remember, this base region when compared to emitter and collector. Another most important thing, emitter region is heavily doped. It should emit large number of charge carriers and large in size when compared to base region. Remember, so size of SE, if I write size of SE should be greater than size of the base. But remember, third point most, the size of the collector region is larger than emitter but less doped. So collector region size SC will be normally greater than emitter. Why normally? It is all power related things. Normally during the fabrication or layout, what we do is, because all the electrons or charge carriers ultimately come to collector, it has to observe, take more number of collectors. So its the size should be larger than even emitter. So therefore, collector will be at the receiving end. Collector name, it collects the charge carriers. Base, which controls this charge carriers. emitter which emits the charge carriers. It acts like a source. So normally emitter region will be heavily doped. So by doping heavily, you get more number of charge carriers. But if the size is more, means it can accept more number of charge carriers accept and at a low power. That means so that it won't, its power is not dissipated much. Yes, these are the salient points. And hence, as the base region is very, very small, base current will be always very small, of the order of microamperes. As a matter of fact, those who know some little bit mathematics, we can say that this base current is nearly 1,000 times smaller than collector or emitter current, because it is in milliamperes, it is in microamperes. So that is one of the most important things. Now, based on the construction, as I've already told you in the earlier slides, so when I want to fabricate or construct a transistor, how do we do this? I take a PN junction, I add one more N, then it will become NPN. I take one PN junction, add one P, it will become PNP. So based on this, according to the names, there are two types of transistors. Very, very, very important. One is NPN transistor, the other is PNP transistor. So the schematic and circuit are shown here. And how do you distinguish while represent in a circuit? How do you represent this in your circuit? With the help of an arrow mark. Always remember one interesting thing. The arrow mark should be drawn at the base emitter terminal, between base emitter terminal only. And also this arrow mark is in a general note. I'll say it should be always P to N. Anywhere in semiconductor physics or semiconductor devices, the arrow mark is always from P to N. Arrow mark is always from P to N. So if I say it is a P to N, it is a P to N means it should be NPN only, because there is no PPN transistor, common sense. So when arrow, otherwise some people generally say when arrow mark is downside, it is NPN, NPN, and when the arrow mark is upside, some people write like this, or even this also correct. So arrow mark is upwards means PN, always I told you PN. So it is PNP. PNP. There is no PNN transistor. You cannot expect that. That's why by blindly you can say PNP. Or this here he has shown emitter upside. Say PNP. So here base is normally P type material. Here base is N type material. It is NPN transistor. It is a PNP. There are two types of transistors. Both are very, very, very important. And we know that they have their own features. Let us see how to construct the transistor, either PNP or NPN. It is very easy to remember or understand. A transistor can be formed by sandwiching, by keeping, by forcing, by inserting a P-type semiconductor between two N-type materials. This is your N-type, this is your N-type, and this is your P. So you get NPN. Remember, this is your base. It is very thin. I have clearly shown here. Similarly, what we can do, I can sandwich one N-type material between two P materials. Sandwich, you know the meaning. In inserting or keeping tightly between two things, between two bread pieces, we sandwich the onions, etc. Then it's called in bakery. You can find sandwiches. Same here also, between two P-type semiconducting materials, we sandwich one thin layer of N material. It will become PNP. Opposite is NPN. So this can also be done or fabricated in other way. That is by connecting two PN junction diodes base to base or back to back. That is, this is a PN junction. Of course, it's our own diagram. So intentionally have some space here. So it is a PN. It is a PN. So they are connected back to back means this will become NPN. Suppose in forward PN, this will become PNP. It's only just to make the students clear about this, I have drawn this diagram. Just only to make the concept clearly. So when I connect like this, so you know that this will become automatically. So that means this will be one diode. This will be another diode here. That's it. So it's combined. It has become P. This is N. This is N. It will become NPN. Only to make you to understand the concept. Here's my own idea. Just don't bother about this textbooks or other things. So this is how we fabricate the PNP and NPN. And what about this PNP and NPN? In a PNP transistor, holes are majority carriers. As you know, NPN, NPN, two N's are there. Electrons are more. That's why electrons are majority carriers. Holes are minority carriers. Holes are PNP. Holes are majority carriers. Electrons are minority. But remember, within the transistor, NPN, electrons will take part in the conduction as well as holes will also take part in the conduction. Same here also, holes will take part in the conduction. Minority carriers electrons will also take part in the conduction. The only difference is NPN means more number of electrons means majority carriers are electrons. Here majority carriers are holes. So this is the basic difference between these two. And this bipolar device, in the bipolar device, that's why it is called a bipolar device, and in this bipolar device we have both what is known as holes and electrons taking place in the conduction. That's why it is called BJT. And these are the two important types of transistors, PNP and NPN. Here I will add one general information. Remember, in between the PNP and NPN transistors, if you are given, if a student is given one NPN transistor and one PNP transistor, normally we have to prefer NPN transistor only. You have to prefer normally NPN transistor is more suitable because in the NPN transistor majority carriers are electrons, and hence as the electrons have more mobility, more speed, the transistor switching speed will be very high when compared to PNP transistor, because in a PNP transistor holes are majority carriers. That means positive carriers are majority carriers, and holes move at a lower speed than electrons. Their mobility is less. That means their switching speed or action is the differences, important differences between NPN and PNP transistor in the table. Just you can follow and by heart if you want for the examination after understanding the concept. In a NPN transistor, the flow of current runs from the collector terminal to emitter terminal. Whereas in a PNP, the flow of electrons runs from emitter terminal to collector. Of course, you know that conventional electrons and hole movement will be always opposite. In a NPN transistor, the NPN transistor is made up of two N material layers separated by a thin P-type. Opposite, PNP transistor is made of two P-type material with a thin layer of N-type between them. That is, by sandwiching a P material between two N materials, I get NPN. By sandwiching N material between two materials, I get a PNP. You can write like this also. In a NPN transistor, a positive voltage is always applied to the collector terminal to generate the current. In a PNP transistor, a positive voltage is applied to emitter terminal to generate the flow of current from emitter to collector. Remember, here from collector to emitter. That's the difference. So here the switching speed of NPN is very high. The switching speed of PNP is slightly less. And conduction is mainly due to electrons in NPN. Remember, of course there may be holes, but mainly due to electrons. Here the conduction is mainly due to holes, PNP, because they are majority charge carriers. So in this class, you have understood what is the meaning of a transistor, why it is called a BJT, how we fabricate in a simple way. We have not gone to details of that, and how to fabricate a transistor. What are the two important types of transistors, PNP and NPN, how they work, their salient features and differences. So in the next video, we'll take up the other parts of or other important information about the transistors, their configuration, characteristics, etc. Thank you.